This is 8.7 part 1, and it's going to be more on graphing quadratic functions. So the first example we're going to get is not going to look exactly like the ones we had yesterday. We're going to graph the function g of x equals x squared minus 6x plus 4. So if you remember from yesterday, we really wanted our equation to be in the form f of x equals a times maybe x plus or minus something, and then maybe plus or minus something on the end, because those things would tell us if it got narrow or wider, or if it was flipped, or if it shifted left, or if it shifted right. Also on this, we're at the end, we're going to label the vertex and the axis of symmetry. So just keep that in mind. So remember that we are wanting this to look more like what I wrote up there. So we can start by maybe putting this x squared minus 6x in parentheses by itself with the plus 4 at the end. That looks a little more like we want it to look. That plus 4 is maybe how it's going to be shifted up. Maybe it's going to change a little bit, hint, hint. But it looks a little more like what we would like. Now remember, what we would really like is for this thing in the parentheses to be something squared. So maybe we could turn this x squared minus 6x, maybe we could turn that into a perfect square trinomial by completing the square. Now the only thing is, if we add on something right there, let's see, I want to change the color here. If we add on something in those parentheses, that was going to change the value of our equation. So if we add something there, we need to make sure and subtract it, the same thing, over here, because that's going to make sure that the value of my function does not change. Let me just move that over a little bit. Okay, so we're going to complete the square. Remember that we take half of our b value, which is negative 6, we cut it in half, that's negative 3, and then we square it, so that's 9. So we're going to add 9 right there, but at the end of this function, we're going to subtract 9, because if I add 9 and subtract 9, it doesn't really change anything. Now let's go ahead and factor this perfect square trinomial. So that's going to be x minus 3 squared. Then on the end, we have 4 minus 9. So that is plus a negative 5, or we could just write minus 5. So we did not change the value of this function at all, I want to point out. We added 9 and subtracted 9. That's fine. You can do that. That's really just adding 0. It doesn't change it. So now, from looking at this, we can see this is going to be the same as the graph of just x squared. Remember, we graphed that yesterday. That's when we start at 0. If we go over to 1 or negative 1, we go up 1. And if we go over to 2 or negative 2, we go up to 4, because 2 squared is 4. So it's going to look just like the graph of x squared, but it is shifted 3 units to the right because of that minus 3, and it's shifted 5 units down because of that minus 5 on the end. So we know that our vertex is going to not be at 0, 0. It's going to be moved over 1, 2, 3 to the right and 5 units down. So it's going to be located at 3, negative 5, our new vertex. So I'm going to go on my graph up here. I'm going to put that new vertex at 3, negative 5. Now, since this did not get stretched wider or narrower at all, I know it's going to look just the same as x squared. It's going to be the same wideness. So if I go over 1 in either direction, it's just going to go up 1. And if I go over 2 in either direction, it's going to go up 1, 2, 3, 4 from my red dot. So I want over 2, up 4 from the red dot, because I know that 2 squared is 4. So there is my graph. Whoa, that was not good. That was a lot better. So there's my parabola. We want to label our vertex. So here's my vertex at 3, negative 5. And my axis of symmetry, we want to draw as a dotted line. And it's always going to be an equation. It's an x equals equation because it's vertical. And it's x equals, whoops, positive 3. Because no matter what, I'm over 3 on the x-axis. All right, so you're going to love this. We just have one more example left to do. All right, so on this example, we're going to graph. I'm going to make it a little tougher by giving us an a value in front of our quadratic other than 1. So it's going to be 3x squared, that's what makes it tough, plus 12x plus 13. So remember, we are wanting this to look like something times x plus or minus something squared. So we want that perfect square trinomial in there, and then plus something on the end. So again, like last time, we can think of this 3x squared plus 12x by itself and then the plus 13. We didn't change anything, we just stuck some parentheses in. Now, we don't want to have a number in front of that x squared because we're going to complete the square just like we did on the last example to make this a perfect square trinomial. Oops, just a second, my phone's ringing. Alright, so I think I was saying that we want to make this a perfect square trinomial, so we don't want that 3 in front of the x squared. So let's go ahead and we're going to factor out a 3 out of this whole thing. We're going to factor out a 3. Don't take out the x squared. an x. I know we can take out an x, but we just want one number on the outside, like that a. So 3 is going to be our a. So we're going to take out a 3. We're going to be left with x squared plus 4x. Now we're going to complete the square on this. So let's leave room to add something on here. And then we've got the plus 13 sitting out here. And then we're going to have to subtract something in the end. But I want to point out something about that in a minute, so I'm not going to write it yet. Just keep that in mind that we can't just add something in here. We're going to have to subtract it later to keep it even. So let's figure out what we want to add here. Remember, we take our b value, which is 4. We cut it in half. That's 2. And we square it. So we're going to add on a 4 right here. Now, here's the thing. That is not really a 4. Do you guys see why it's not really a 4? Because it's really 3 times 4. This is actually a 12 right there. We really just added on a 12 inside those parentheses. So we have to subtract a 12. That is so super important that you catch that. That's really tricky. So now, come to class with a question about that if you don't really see what happened there, because it is tricky. So we've got a 3 here. We made this a perfect square trinomial, so it factors to x plus 2 squared. And then on the end, we have 13 minus 12, so it's a plus 1 on the end. These combine to the plus 1. So now we know a few things happened here. We know that this is going to be narrower than the graph of x squared. We know that it's shifted to the left 2 units, and we know that it's shifted up 1 unit. Now, since it became narrower, we cannot just graph it really quickly. We've got to make an XY chart here. So I would say with our XY charts, let's always start with the vertex on here. So the vertex, it moved left 2, so that's going to be a negative 2 for the x value and up 1. So my vertex is usually at 0, 0, but it moved left 2 and up 1. So it's at negative 2, 1. That's my new vertex. Now remember, this graph is going to be symmetrical. So maybe I'll go 1 lower than that x value to negative 3. And then I'll go 1 higher up to negative 1. Those should have the same values right there. So let's just plug in one of them and then we don't have to do the other since we know it's symmetrical. So let's plug in the negative 3. So I'm going to be doing 3 times negative 3 plus 2 squared plus 1. So I'm just plugging in a negative 3 to that equation. I'm going to see what the value is, and then it's going to be a lot easier to graph it. So let's see, negative 3 plus 2 is negative 1, squared is 1, times 3 is 3, plus 1 is 4. So this is 4, this guy's 4. And you know what, guys? I'll just be honest. This one's it's going to be tough, so let's just graph those ones for now. Usually I make you do 2 on either side of the vertex, but let's just do 1 for right now. So my vertex is at negative 2, 1. Here's my vertex. And we are going to go to negative 3 up 4. That's that point right there. Negative 3 up 4. And to negative 1, 4. If if we go over one more, I tried it on my paper, it makes your y value all the way up to 13, so I just thought we'd leave that one off for now. So we've got our vertex, and let's label our axis of symmetry. That is x equals -2. So 10 minutes, nice, that's one of my shortest ones ever. So come to class ready to do some problems on that.